Okay, so just to let you know what a dependent event is, it's an event that affects the other one. So a lot of the times, having a not replacement affects your second. Like if you're going to do 2 draws of cards from a deck or bag of marbles or whatever like that, if you keep your first selection, that changes the odds of the second pick of something. Okay, that's a dependent. Independent is when one has nothing to do with the other. They don't affect each other. Okay, so usually if you draw a card but then replace it, okay, then there's going to be no effect on the second try. Okay, so a computer manufacturer knows if they have 100 chips in a box, 3 of them would be defective. Jocelyn draws 2 chips at random from this box of 100. Determine the probability that she will draw 2 defective chips after not replacing the first. Okay, so my first draw, what are the chances of me picking a defective chip on the first try? How many?
3 out of 1.
3 out of all possible 100. Okay, then you don't replace that. So you're visualizing yourself taking that chip and then you just put it in your pocket. Now you go back into the box. So how many options do you have out of how many possible now? 2 out of 99. Okay, and I'm multiplying it because we're doing this and then we're doing this. We're doing them as one situation. Okay? Okay, we got a dice and coin game. So this is what's happening. Determine the probability that Mokhtar will get 1, 3, or 0 points on his first turn. So, what's going on? Points are awarded for rolling a 6 on a die or getting a heads on a coin. So you get 1 point for getting an either. You get 3 points for doing both, and you get 0 points if neither thing happened. Okay, so what's the chance of rolling a 6 on a dice? 1 out of 6. And the chance of getting a head on a coin is 1 out of 2. Okay, so you get 1 point if either thing happened. So this might happen or this might happen. Okay, so the chances would be that you do roll the 6, but you do not get a head. Or so to get 1 point, you're going to roll the 6, but then you get a tail because one of the events had to happen. Or the other way around would be that you didn't roll the 6, but you got the head. That's how you can get 1 point in the game, right? Does that make sense? One of those things is happening. So if this happens, it's saying this one doesn't happen. Or if this one doesn't happen, that means that one has to happen. Okay, so how do you get a 6? 1 out of 6. What's the chance of you not getting a head on that coin? 1/2? Or, what are the odds that you would not roll a 6? 5 out of 6 times you won't get that 6. And then what's the probability that you get that head? So this is 1/12. This is 5/12. So 6 out of 12 times, you're going to get one of those scenarios. And either or. One of them is happening with one of them not happening. Okay, so it says to score 3 points, both things need to happen. So you would have to roll a 6 and you would have to get ahead. You'd have to have both things happening. So what is your probability? 1 out of 6, 1 out of 2. Okay, to score no points at this game, it's because you want neither thing to happen. So I need to not roll a 6, and I need to not get a head or a tail, right? I need to not be rolling a 6, and I need to not be getting a head. So what is the option here? So if I don't get the 6, 5 out of 6, right? To not get that 6 on a die. And if you're not getting a head, you have a half chance of getting that tail, which is 5 out of 12. Okay, so there you go. There's the odds that you're going to get one of the things and get 1 point, your chances of getting both, and then you get a 3 point, and what's your chances of getting none of them, and you're going to get a 0 point on your turn. Okay, what do you notice about all 3 of these together? What would they do together? If I put this, this, and this together, what happens? 100%. Okay, why is that? It's because these are the only options that could happen in this game, right? You're either going to get nothing, you're going to get this one but not, you're either going to get not this and this good, or you can get both good, right? Those are all the possible outcomes, so therefore these all should add up to 100%. Okay, 1,000 tickets for charity placed in a drum. There's going to be 2 draws. The first draw, grand prize, second for consolation prize. After each draw, the winning ticket is returned, so you can draw and win both things. Max bought 5 tickets. What's the probability to 0.1% that he will win at least 1 prize? So that wording, at least 1. What does that mean? At least 1. He could win 1 or he could win both. So let's talk about he could win and then lose, right? The first draw he could win, but on the second draw he wouldn't. What else could happen? Lose, win, or win, win. Okay? This situation would have been the same as when we were doing, one of them is going to be a win, and then you would times it by 2, choose 1, because you're choosing one of the events to be that win. Okay, so what's the probability of him winning? 5 of his tickets out of the 1,000. Remember that we replaced the ticket. The ticket got put back in. So now on the redraw, what's the chance There's still 1,000 tickets in there, right? Because you put it back. How many lost tickets would be in there? 995. Okay, this will be the same, right? Just in the reverse order. So basically that's why we just times it by 2, because there's 2 choices for where you're going to put that one win. So if you win and you win, okay, these are all separate scenarios. So what are we doing? We're adding them together. Okay, and it's looking like a small number because it says to round to 0.1%. Am I matching with you? When it rounded, I basically just said, well, that's rounding to 1%. Okay, there is a total different way I could have done this question. All minus opposite or the complement event. So all would be 1,000 over 1,000, right? Those are the probabilities of getting all tickets. Minus, so what's the opposite of having these situations? What's the only other event that could have been possible? A lose, lose. So a lose, lose. Okay, and then you should get to the same number. Okay, that kind of makes sense. You can see all the scenarios mapped out. You could do a win-loss, loss-win, a win-win, or a lose-lose, right? Those are the 4 possible situations. How would your results have changed if you didn't replace, if you didn't make a replacement? So let's do it as the all minus opposite way then this time. So the all, 1,000 over 1,000, minus the opposite event. So what is going to happen now? We're going to lose-lose, but what's the scenario because we are not replacing that ticket?
The same as times 994 over 999.
1 less, 1 less, yeah. So that's kind of the idea, okay? You would calculate it, but we're going to move on. Okay, so just what's happening. Okay, Tanya estimates that her probability of passing French is 70%. Her probability of passing her chemistry class is 60%. Determine the probability that Tanya will pass both, pass French and fail chemistry, pass both, or fail both, pass one. Okay, here we go. Passing French, passing the chemistry, 0.6. So that is 0.42. Right, because 6 times 7 is 42. This one says you're going to fail chemistry. So what's the number for failing? If you're going to pass with 70%, what's the chances that you're going to fail that? 30%? Did you think that? If you have a 70% chance to pass the French.
You're passing.
Oh, sorry, you're passing French. I'm getting ahead. Passing French, 0.7. Now do the fail. Failing chemistry. So if there's a 60 pass, there's a 40 fail rate. So 28. Fail both. So now that's a 0.3, 0.4. And then this one, pass exactly one class. So you could do a pass, fail, or you could do a fail and a pass, right? Pass, fail. We just did that in question B where we passed French and we failed chemistry. We did that on question B. So what would be the flip? We would have to fail French, but we would have to pass chemistry. Okay, that was good. All right, a couple more and we're done. Jars of marbles. 10 blue, 8 red, 5 green. Probability, you draw a blue and then a red without replacing. So a blue, I would have 10 out of, did anybody add them all up? 23 marbles. Then I need to get a red. I didn't put my marble, my blue marble back. My blue marble is now in my pocket. So how many red marbles? 8. How many marbles are in that bag though? 22. Question B, you draw a blue and then a red, but you put it back. So you draw that blue, so that's the same. Then you draw the red, so the 8 is the same, but the only thing that changes in this question is the 23 on the bottom because you put that back in. Okay, last question on this. You draw 2 of the same color without replacement. Okay, so there's a bunch of different scenarios that could happen. If I'm going to draw 2 of the same color, what could I get? I could do blue, blue as an option. Or, there's other draws I could do. I could go red, red, or green, green. Okay, because it just says same color, so it didn't say which color, right? Okay, so blue is 10 out of the 23. And remember, you do not put it back in the bag. And then if you were to get another blue one, it would be 9 out of the 22. Okay, can you keep going? Red, red. You're not putting it back after your first draw. Okay, always be thinking about what are the scenarios, what's happening, thinking like that. Okay, last question. You're going to get 4 cards to pick in the deck. What's the probability that you're going to end up with 4 aces on your pick? Okay, think about that. That's going to be pretty low, right? Okay, so the first one says without replacement. Okay, so 4 out of, what's the card situation again? 52. So if you do not replace, then this goes down, 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 down. So just how do you change the question if I change it to you make a replacement every time you put the card back in? So what do you do now? Every chance would be the same. It would be an independent situation. This one's depending because this affects that. Okay, but this one is not.